this is Sean Parvini, and in this video I'm going to show you how to actually construct a normal probability distribution approximation to a binomial probability distribution in Excel. So by the time we get done, you're gonna be able to do something what I have here on the screen. Of course, I'll do this from scratch so you can follow step by step on how to get this beautiful normal curve on top of any binomial distribution. So in this example that we're going to do step by step, I'm going to assume that I want to fit a normal distribution, that's the blue curve, overlaid on top of a binomial probability distribution. So for example, this example that I'm using, I'm going to go with binomial, the parameters number of trials 20, and probability of success is going to be 0.5. Okay, so first I need to create the outcomes for the binomial distribution. So usually we use the variable, random variable x is what represents the outcome, or just the random variable x, then the name. Now because n is going to be 20, so number of successes could go from 1 to, or for 0 means no success, all the way to 0, 1, 2. I'm going to take advantage of Excel's capability here and try to copy this all the way down to 20. And there you have it. I need one more here, 18, 19. Next one's going to be 20. Okay, so these are the number of successes in my binomial experiment. Okay, next I need to label this B for binomial, parentheses, my number of trials n is 20, and probability of success, and I chose 0.5 just because you see the perfect symmetry at 0.5 of the binomial distribution. It looks better. But you can choose any probability, of course. Now here I need to actually enter the command that generates the probability of 0 successes. Now the Excel command, you can use equal sign, so I'm going to hit equal. Let me enlarge this portion a little bit. Hold on. There you go, so you can see a little better. You can hit equal sign in that cell, or you can hit plus sign. Both of those tell Excel that you're about to enter a formula or a mathematical expression, or a numerical value in that cell. So I'm using equal sign here. Now the command that I need is binom, and notice as I type in binom, you get a whole alphabetical list of possible commands that begin with those letters. The one that we actually want is binom dist. So you can at this point double click on that function, and Excel displays actually the parameters of that built-in function. So notice it's boldface on number S, that means number of successes. Now because I'm going to copy this down for the remaining outcomes 1 through 20, so instead of typing a 0, which you could, there you go, that would be the number of success. However, it's better if I click on 0 in that K6 cell. So notice, there you go. So in other words, I'm saying number of successes is whatever is in that cell. And then put comma. The number of trials, that's fixed, 20. So I don't need to point to any cell. That's going to be fixed, 20. And it's not going to change during the copy process. And then hit comma. Now the probability of success, remember, by definition of a binomial experiment, probability of success must be fixed, and it never changes from trial to trial. So that's going to be the 0.5 for us, and then comma. And at this point, this is pretty descriptive. The option is true or false. That's the last part of this command. If you hit true, then you're going to create a cumulative distribution function. That would be probability of the outcome and everything below it, which at 0, of course, there's nothing below it. So it's going to be exactly the same as probability of 0. But for future outcomes, this selection will make a difference. So if you want to, for example, know probability of x less than or equal to 4, once you copy this formula for x4, then you choose true, and that gives you probability of less than or equal 4. But we don't want to do that, so I'm going to go false. When you hit false, then all you're requesting Excel to give you, the function will give you what we call the probability mass function, which is just probability of a single outcome. That's what, think of it as that. And there you go. Now this is of course in scientific notation. That's a very small probability, almost a 0. That's 9.5 times 10 to negative 7. So if you want to write it as a number in general format, that's going to be imagine 6 zeros in front of a decimal point, 6 zeros, and then you have 9, 5, 3, 6, 7, 4, and so on. But I'm just going to keep it like that because our purpose is to graph the normal distribution. Now, from here on out, I'm just going to copy this formula. And don't worry, we don't have to type every time, because the way we describe this function using that K6 is really going to help us be able to copy it. So at this point, to copy, there are several ways to do any task in Excel. The way I like to copy is you can go to a lower right corner of that cell, and you see that plus sign. You see the plus sign there? If you left click once, hold, don't let go of the click. So left click and hold once, don't double click. And then drag it all the way down to 20 and then let go of that left click. So once you let go, there you go. All the probabilities are copied. So you don't have to do this one by one. So for example, probability of 7 successes, there you go. It's binomial dist. K13, notice the value that sits in that cell is 7. So that's K13 value. And then of course, N is 20, P.5, and the other parameters of that function will not change. So there you go. We created our binomial probabilities. Okay. Now, you can of course jazz this up however you want to do. I promise I'm going to make it look like this, right? So I'm on my way to that. Now, next I need to create a column of normal distributions. So step 1 is to create the binomial probabilities. Step 2 is to create the normal probabilities. So I'm just going to type N for normal. Oh, before I do, sorry. Let's go back here. Now, the theory that actually helps us do this, which is basic simple theory here. In order to draw a normal approximation to this binomial, specific binomial distribution I have selected, I need to know the parameters of the normal distribution. Now remember, the parameters of a normal distribution are its mean and its deviation. So what mean am I going to use for my normal distribution? Well, stands to reason that I'm going to use the mean. That's the mean of the binomial distribution. The mean of the binomial distribution is its expected value, or mu, times, mu is the expected value, is given by the formula N, the number of trials, times P, probability of success. So in this case, I'm going to go, the mean is going to be what? NP, so that's 20 times 0.5. That's the mean. The deviation is going to be square root of. So I'm going to go plus SQRT. That's the square root of. And then it's going to be NP times 1 minus P. Again, N in this case was 20 times P was 0.5 times, and then 1 minus 0.5 remains 0.5, but just to see the formula, it's 1 minus P. There you go. And then close paren and hit equal. Yes, that's fine. Okay, so I must have missed the parentheses. Yeah, the last parentheses I missed. So anyway, there you go. So you're looking at the command that creates the standard deviation. Again, it's the square root of N, P, and then 1 minus P. Okay, perfect. Now we are in a position to create the normal probabilities. So to create the normal probabilities, first to label this, I'm going to go N parentheses. the mean was 10, right? The mean was 10, comma, and the exact standard deviation is the square root of np1 minus p. That product actually is going to be square root of 5. The radicand is going to be 5. That's 20 times 0.5 times 0.5. Now, how do I insert the square root in there? I'm going to go to insert, and we're going to insert the symbol, and there you go, symbols. And I have a square root symbol here. Now, in case you wondered, you may get a different dialog box. It may, let's say, it may start like this with you. So that's no big deal. You just click on the subset here, and you scroll down to mathematical symbol, right? So there you go. In here, mathematical operators, and that's where you see this. And there's the square root symbol here. Okay. It doesn't have the vinculum that goes to the top right. It just has that square root symbol abbreviated like that. And insert, and there you go. Close. And now it's in there. And then I'm just going to type 5, close parentheses. So this clearly identifies the normal distribution that I'm going to be working with. Okay. Now, how do I get the normal probabilities in this case? The normal probabilities, again, Excel has a built-in function. I'm going to hit equal to. This time, if you go norm, and again, there's a whole host of functions that begin with the word norm or has somehow norm in it, such as, for example, here, log norm. It doesn't start with norm, but it does have norm in it. So, of course, it's lexicographic. That means in alphabetical order, correctly listed the way the computer lists it. So our command is going to be norm dist. There you go. You double click on that, and it gives you, again, the parameter. This is what Excel needs in order to correctly calculate that probability. First, it needs the outcome. Remember, I like to point to the outcome. This is for the copy. When I copy it next time, then I just simply drag and copy it, so I don't have to retype the formula 20 more times. And then comma, and when I hit comma, notice the boldface X is going to jump to mean. It's going to become boldface in a moment. And there you go. So it's okay, where's the mean? Now, my mean is 10, but if let's say you have different mean that ends up with a whole bunch of decimals, again, here's where you would like to point to the cell, so you don't have to type that long number if that's what you like to do, or you can just type 10. So I'm going to actually point to it, okay, and then comma. So okay, what is your standard deviation? Now remember, standard deviation for us is a square root of 5. So at this point, you can actually go square root of 5, type a square root of 5 here, or you can point to it. There you go. That's the square root of 5. So I don't have to type that decimal. And also internally, actually, because these values are stored, I believe double precision means with 16 decimals. So this way you're going to have less of a rounding error also. So that's why I like to point to the cell where the formula resides. And just like in the case of a binomial, now the next field is asking me, is this a cumulative distribution function where you accumulate probabilities across the values from low to high? Or is it just a probability, again, mass function, which Excel calls it? Again, this is a probability. It's really not probability in this case, but it's the value of the function at that point, because probability for a continuous distribution at a point is 0. So think of it as the value of the function at that point. So I'm just going to go, in this case, false, because I do not want a cumulative probability distribution. And there you have it. So next I'm going to copy this, but before I do, because let me just show you one thing here. I'm just going to copy it one time. There you go. Now notice there's a problem here, right? It says value. There's something wrong here. If I click on this formula to see what happened, well, the value of the outcome is K7, which is now that's true. I want to find the value of the function, not the probability again. It's the value of the function at this point, the normal function when x is 1. So I'm okay with that. But remember, the mean was 10 in cell M3. Notice it now has moved to M4. Same thing with standard deviation, was in M4, it's in M5. That's because in Excel, all addresses are relative. So that means when you copy them, it's relative to the prior cells. So in order to fix this, to correct this, I need to freeze, is the proper terminology here. I need to freeze these two cells where the mean and deviation is, because I don't want those to change throughout the copy process. So if you put $1 before M and $1 before 3, that will freeze that cell. So whether you copy across in a row or in a column, those two numbers will not change. That's called freezing the cell. So I just froze those cells. You can read more about how to freeze cells in Excel. It's a really interesting feature, so you can learn more about it. So there you go. Nothing's changed. Now I'm ready to copy this. And when I copy it, remember, I click in the cell once. You don't need to double click, because if you do, this is what's going to happen. A single click. There, single click. Go to the lower right corner and drag it all the way down. And there you go. Now you got your normal probabilities. And if I click, for example, right in here, double click, now look at how the fields are filled out properly. K15 means I want to, again, I'm going to do a normal distribution evaluation. When X is 9, that's in cell K15, K and 15. And notice M3, mean is 10, and M4, deviation is that. Those are frozen. They don't change. Escape out and look at this one. See that M and M3, M4 never changed. Only K changed. And that's exactly what we wanted. Okay, perfect. So we got this. I can now kind of do some cosmetics. You see me do that throughout this presentation. I do a lot of cosmetics, trying to make these aesthetically nicer so they look good. All right. Oops, I didn't do this correctly, did I? Because I missed out. No worries. It's good. I can show you now how to clear any errors. The problem was I did not correctly border this thing to where it covered X21. Now it does. And then I like to do this one. And if you want, you can actually use a different color for these, the outcomes. Again, this is all personal preference. Okay, and left that one out. No border, and then now actually I want to have a border here. Okay, so now we have our probabilities, right? Now the important part is the graph. Okay, so how are we going to do this? I'm going to go to the right of the table, and then I'm going to go insert. Okay, insert. We're going to insert the graph, right? So at this point, I'm going to go insert and then move over to the gallery of charts that you have here, all possible charts. And then I'm okay with this one. I'm going to insert a column or a bar chart. Click, and then just choose the first one. 2D is fine. Okay. Now there you go. There's nothing there, right? But no worries. We'll fix that up. So far we know what kind of chart we want, right? Now if I right click, see, I've activated the chart area. Right click, and when we right click, we're going to go select data. There you go. You go select data. The chart data range, that's what I want to do. So click here, and this is going to be my chart data range. Okay, enter. Now at this point, you get something that doesn't make sense. All it's doing right now is plotting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that, and whatever. It's not what we want. Okay, but don't worry about it. Now I'm gonna deselect X, okay, because these are legend entries. These are your series actually. X is not my series. My series are binomial and normal. So I'm just gonna deselect these, and I'm the one X is selected. I'm going to remove right here. See that? I'm going to remove X. So we don't want it. And then keep these selected now. Okay, I'm going to then edit my horizontal axis labels. Notice it starts with 1. It's supposed to start with 0. So I'm just going to go edit on that. And then this option here means I want to point to a cell. Do you see that arrow pointing? What is it going to point to? We're going to point to the cell. So I'm just going to actually highlight from 0 to 20. Enter. Aha. And then click OK. And so far so good. I'm just going to X out of this one. And I just realized left the highlight on 20 and boldface it. Now that looks good. Okay, and where did it go? So let me go select this, select data again, and this is good because we get to review what I just did. So here's my selected data. Delete X here, remove. Oops, sorry, didn't want to do that. No worries. If we do something wrong, we can always fix it. There. And uncheck. Now click X, remove. X is gone. So anyway, so I have selected again my series. Let me edit my label range from 0 to 20. Enter, and we are okay now. So there you go. That's the chart. It's almost like what I have here, right? There you go. Now we're almost there. If you want to add a label here, by the way, a chart title, you go to the plus, and then there you go, chart title. And you click on that. So my chart title now, I'm going to actually call this normal approximation to binomial probabilities. Normal approximation to binomial probabilities. Okay, I'm happy with that. So that's our chart title. As far as the chart itself goes, notice that there are no borders on the chart here. If you right click and go format chart area, this is where you can actually create borders if you like to. You see that border is solid line if you want, and there is now a solid line around this chart. If you don't like a solid line around the chart, you can easily remove it. As far as data labels go again, if you click again on the chart area, you can add my legends. Oh, let me go through this. The axis title, that's right now. Let me go back. Notice there are no titles on 0 through 20. I want that to be X, or you can call it number of successes, whatever descriptive label you want. The vertical axis, these are values. In the case of the binomial, are their probabilities, and in case of the normal distribution, it's going to be the height of the function at that point. Remember, for the binomial, they are probabilities, but for the normal distribution, they are not probabilities, okay? Because at 10, for example, although you see a height of almost 0.18, but that's not the probability, because probability at the point is 0. Okay, now let's see. So what I want to do is actually, if you go here, and I activated the vertical axis, okay, and you can right click format axis, and then in here is where you can, for example, change the number on the bottom. Change the number to, instead of general, you can change it to a percentage if you want, or keep it as a decimal, whatever you like to do it. Okay, so you can add descriptive labels this way. So let me go to plus, and I'm gonna add data labels. I don't want that. I want to go axis titles, and the axis title here, I'm gonna call this just X. How's that? Axis title. I'm just gonna call it X. and let me boldface it. Alright, so that's done. This other axis title, if you want to just oops, I didn't want to do that, sorry. Oh, by the way, if you accidentally, like what I did, I deleted something, you can go back here, and this arrow up there, this is your undo button. You just click on that icon, and there you have it. Okay, so let's actually, the other thing I want to do is I want to get rid of the grid lines, format plot area, and to get rid of the grid lines, let me see, format axis, and there should be tick marks here. Let me see. So I'll show you how to do that later without grid lines here. Okay, so let's create the normal distribution. To do that, you select, there you go, make sure you select the normal series, this one. Okay, and what I'm gonna do is I'm just gonna go to insert, where we actually selected the bar chart here. Don't do that. Okay, I'm gonna go insert, and while this is selected, you go to here, the list of line chart, click and select the first one, line, and there you go. There is your normal distribution overlaid on top of that binomial. Now the other thing, the only thing that I need to do here, and we're done, the rest is just enhancing the graph however you want to do it. But notice at this point the normal distribution looks like a sort of a frequency polygon, where you have this straight edge that connect to each other, just like they do in a polygon. There are straight line segments. I would like to make that smooth. Okay, so we need to smooth over this thing. Okay, that's what we're gonna do next. Okay, sorry about that. I had to pause for a moment. Okay, so at this point I would like to smooth over the curve, right? Smooth over the curve. So again, I can select, there you go, you can select the series, and in this case I want to select the normal distribution, right, which is selected right now. And if I right click, format, I don't want to format data point, I want to format the series. Okay, so let me do that. Alright, so I'm going to again select my series, and there you go. Right click, format data series. Now this time again we want to smooth over it, so click on this fill and line option to format, and if you go down, all the way down here, it says a smoothed line. Check on that and look at the normal distribution. There you go, and you get exactly what I got before. So you have this beautiful normal distribution overlaid on top of the binomial. Now as far as the smoothing techniques here, it's difficult to find this in Excel literature, at least I couldn't find it, but I really believe the way this curve is smoothed is that Excel is most likely using a procedure called Catmull-Rom, the name of two individuals, Catmull-Rom, that's C-A-T-M-U-L-L, and then hyphen Rom is R-O-M. It uses a Catmull-Rom splines method, and what the spline is simply a piecewise polynomial function. So what Excel is doing at that point is doing a polynomial interpolation of adjacent cells, and I believe it tries to fit a third degree polynomial between adjacent points. Okay, so that's what it's doing, in case you wondered. Now, so we got pretty much right in here. Look at what I had. I promised this is what we're gonna do, and that's what we have. So the last things here, again, some sort of cosmetics if you're interested, to get rid of the grid lines here. Okay, to get rid of the grid lines, you go plus and grid lines. They're gone. You see, you toggle back on and off. So grid lines, no grid lines. I like mine with no grid lines just because they're visually distracting. They take away from the graph itself. The other thing is the bar width for the for the binomial distribution, you can change the width of these bars. You can go to bar, and there you go, gap width, and you can actually slide the slider here. There you go, very tiny, which is what it's supposed to be. Look like spikes at 1, 2, 3, 4 like that. Or you can move it to the left, and you can change, and there you go. If you want, you can shut it. There you go. And that would be the binomial distribution. Some textbooks, statistics textbooks, report the distribution like this. I personally don't like that, because that takes away from the discreteness of the distribution, because we're supposed to have, gaps between the numbers, and this way they don't. But to each their own. If you want, you can adjust the gaps this way. Whatever works for you. And here we have it. And also the colors, if you want, you can change the colors. So the way to do that, you click here, and right in here are your choice of, there's your color palette. To get the one I had, you can just, there you go, you use some kind of a shading here, a grayscale shading, and that is exactly what I have here. There you go. Okay, the only other thing I want to do to finish this up is to create legends. So inserting legends really help when you have several series. So when the reader looks at your charts, they know which series represents which chart, which bar or line in your graph. So to add legends, you go to chart elements, and let's see, right in here, legends. Now you have option with the legends where you want to position them. This is top, and you can go to, for example, the way I had it, bottom, or you can go to the left or right, doesn't matter. There you go. But the other thing you can do with legends, by the way, you can also click on the legend and actually move it. You can actually move it to where you like it to be, where you like it to go. So in this case, I'm going to move my legend here. And I believe that was the only other thing I wanted to show you. And that's about it. Let me just change the color to blue here for my series. And with that, we are done. We achieved what we were here for. So this is how you overlay a normal distribution, probability distribution, on a binomial probability function. So with that, again, I wish you the best and good luck to you.